Hey there. I'm going to try to add a nullish coalescing operator to my language here. We already have optional types, so this should be pretty straightforward. The thing I want to do first is write a test program that fails to compile, fails to parse even, and we'll go all the way from completely failing and unsupported, hopefully, to implemented. Let's see how long this takes us. So the first thing I want to do is we'll just make a new file in the root of the project. We'll name it in a moment. No need to name it just yet. We'll return 0. So the idea is we want to have an optional value. So we'll call this maybe point. And that's going to be equal to x 10, y 10. And that's going to be equal to sum of that. So that it is a, and then we're going to call this optional. I called it, yeah, saying nullish. This is because it's called that in JavaScript because nullish refers to null and undefined. This is just the non-coalescing operator. Actually, I don't even need one. Let's do this. Let's define a type. All right, I'm making it too complicated. Maybe num int, and then we're going to assert. We'll do valid result. Maybe num or 42. Assert result 42. And then this could be turned to a one-liner later. We're going to say none. It is going to need a type though. We could do it this way. We'll see if that one works later. For now, we'll split it out into 3 lines. And let's just try to run the file. Run file. Expected end or definition, but got question mark. So this is a problem in the parser. Let's get in there. And I want to fix this end or definition. This always confuses me. Expected end of file or start of new definition. Always confuses me, and I want to read it as end of definition. Okay, so let's go to the Lexer and say token kind. Oh, I have a way. Okay, token kind. Do we have question mark? Yes, because it's used for. It is used for optionals, so this is really nice. I didn't even give any thought to whether I like this syntax. And I wonder about just using the keyword else. The parsing implications for this would be after parsing an expression, we look for postfix operators where the keyword else counts as a postfix. Or we do it as a binary op. Like and. Really, it is serving that way. Do we use the question mark? The double question mark, I think it's dumb. I read it as maybe num 42. I like else. I like else a lot. Cool. So we already have keyword else, keyword else, and then so let's talk about binary operators. Is binary operator? And we say something is a binary operator if there's a binary op kind from its token kind. So we're going to make else a binary operator. And this is going to be binary op kind, optional else. I like that. I like that a lot. Optional else. That'll just be else. I want this to have a pretty low precedence. Okay, so I'm all the way down deep into type checking. So by doing this as a binary op, which I guess it was all along, we actually don't have any new parsing to do. We actually don't have a lot of plumbing code to add because it's kind of like we're reusing. We get to reuse a lot of code for binary ops that just works. Parse the left-hand side, parse the operator, parse the right-hand side, evaluate the left-hand side, evaluate the right-hand side. And now we get to here. So here we've evaluated both sides. Now, this is interesting. Yeah, we can go ahead and evaluate both. We're expecting matching sides. So this is our first. Let me check if this is true. I want to say this is our first asymmetric binary op. Take a bite. With the left-hand side, let me show you what I mean. We expect the right-hand side to be the same type as the left-hand side. And this is not a hard check, but this does inform inference and some other things, some automatic coercion. For example, from a value to an optional of that value. So we only something like this. If kind dot is symmetric, then op. Oh, I have Copilot on. I think I want it off. I turned it on for something last night to write some sorting code. Is symmetric then op? Some LHS get type else none. Oh, okay. Can go ahead and define kind up here. And now I can just generate the method. So here now we're in binary op kind. Match self. I don't like doing the underscore because invariably I will accidentally not update this. Yeah, I'm not gonna do the underscore. I'm gonna be good. I just need let's just ask Rust Analyzer to do this for me. And now we'll replace all these instances of to do. with and now don't forget to use our expected type here. And this is a big fix me actually. Type checking for bin-ops is just kind of broken right now. I'm just checking that the LHS and the right hand side are compatible. If mine is symmetric bin-op, else what do I want to check? So RHS must be LHS must be an optional, and RHS must be its contained type. Let me go back to our sample program. And think that through. Yeah, it has to be an optional, and this has to be, yeah, the thing that it contains. Okay, quick pause there, finishing up a snack. And let's run the program and then we'll type check this. So what is the result type? If the result type is optional else, then it's going to be LHS get type, self types get LHS get type, expect optional, inner type. We can expect optional, which will panic if it's not, because, oh, or just RHS get type. And because we will have checked this above, right up here, we're going to check this. I guess I could do the type checking down here, but I'm doing the other type checking up here, and this is for the result type. So anyway. Else can only be used. Else operator can only be used on an optional. Type was I want the LHS span. It's not quite right to use the whole op span. I'd much rather use the LHS span. But this is what we got. And this is going to be self dot type ID to string LHS get type. Let RHS the reason I have to get type and get type is this is a type ID, and then this is doing a lookup in the pool. So it's really lightweight to use IDs everywhere on the actual structs for copying around and lots of different reasons. And then we actually looked them up on our basically like our database of types, which is secretly just a vec, but it's called internment. And it's a nice way to get around the borrow checker as well as make things fast. And everything has an ID, which makes me comfortable and happy as a web dev by day and by trade. Okay. If let error message equals self.type check types. So they don't need to be identical, but the thing that's in the thing on the right hand side of the else needs to be compatible with the thing inside. So we're going to call type check types where the expected is the thing inside the left hand side and actual is the right hand side. So expected is going to be LHS optional.inner type. Inner type. Actual will be RHS type, and the scope ID is hopefully just the scope that we have. Then we're going to return make, oh no, make fail span here. Make this even bigger. It's so hard to program with font this big. I don't think you understand. It looks normal on the video, but man, is it huge in front of my face. We'll format this. The span is can just be the binary op span. We can improve that later. The main idea is that I don't want to say left-hand side, right-hand side. I want to be a little bit more colloquial here. I want to say, what is the right-hand side of the else? The fallback value or the I don't know, else. We'll say else value must invalid else value incompatible with optional. So we're type checking it. Yeah. Okay, so I branch off for equals, not equals. I'm wondering if everything I've done is in the wrong place. Because what I do, equals and not equals are very different than the rest of the binary ops. The rest of the binary ops end up doing like operating on scalar values. And equals, not equals end up calling functions. I think optional else is going to be special like the others, and I'd rather not have it feel very special down in code gen. I need to just desugar this to an if else. Is that possible? What type do I need to return here? Yeah, actually. So, well, what's nice is I can keep all the code I've written, and I can make this special case for optional else, where, okay, I guess I'm almost at the end anyway. Here I emit this binary op, and what I think I want to emit instead is just go ahead and desugar to an if else. Which means I got to synthesize code, which is always a lot of writing. But I think this is good. This is where doing it as a binary op feels uncomfortable. I am going to, it's funny, equals and not equals I'm handling here, even though they've definitely been handled here. I think it's probably better to panic equals panic should be special cased by now equals I think that's better, and I'm going to do the same. Optional else be special cased by now, and I'm going to come up here. We're going to take the work we did for optional else, and we're going to say binary op kind optional else, and we're just going to do all the work in line here, and then we're going to pull it out into a function like we did for equality. So we'll just do this here, and ultimately we're going to return a typed expr if expr. No, that's the parse one. Typed if. Is it typed if? It is a typed if. Condition consequent alternate type span. Perfect. I need RHS and LHS. Yep. We may still have symmetric bin ops. Down there, so I won't remove that check. But here we definitely don't. I could pass the expected type of the inner type of the optional. So this could be a to do enhancement pass type hint to RHS based on LHS optional inner value. This would also result in us type checking earlier, which would be a good performance improvement. So actually, let's go ahead and do this. So the idea is that if the left-hand side is not an optional, we don't even need to evaluate the right-hand side. So we're already getting benefits from not sort of reusing the flow from binary ops. We could have done this, but it would be gumming up the rest of it with all these special cases that are just for this one operator. So we have this, which would mean we actually can pass the LHS optional inner type as the expected type. Now this doesn't cause it to fail if it's not that type. What this does is it causes it to use it as a hint, which means we'll do some coercion and lifting and other smart things. My favorite example is like if you have an empty array, based on the type hint, we would type that as array of int or array of bool or array of foo, right? So yeah, lets us type things. This would let us use an empty array for an or else, which might actually be kind of what we want. If we had an optional array or elsing it to an empty array, this type hint is what's going to allow that. Okay. You just want a type ID. So I never even needed that, which is nice. Okay, so the condition is going to be LHS has value. Let LHS has value. This is where we start meta programming. We're writing the code. That is the code. If that makes sense. So we're writing the LHS has value expression. That's going to be type expr. Sorry, optional has value. Sorry, let me look up what it's called. Oh, I see. It just takes a typed expr. So box new LHS variable. So here's the thing. We can't just use binary op LHS. We can't just use LHS here. Because then that expression, oh no. Maybe we can. So we're desugaring this. You go to the program. So I always like to write out the desugared version. So the line 3 becomes if maybe num has value. I forget how you do it. I think it has value. Maybe num. Yeah, here's the problem. So else 42. Maybe num dot yeah, and unchecked unwrap. So here's the problem. Maybe num here is just a variable reference, but let's imagine that it was side effecting. So maybe num is a function that prints stuff. You can't just place this expression in here. So what you have to actually desugar to is this. To desugar to a block of code. And you have to say, okay, val LHS value equals maybe num. And this is just the copy, the expression that the user wrote, right? So you have that and you use it, and we're gonna reuse that now. And now we're gonna say if LHS value has value, then that's gonna be LHS value force unwrap else 42. So actually what we're desugaring to, unfortunately, is a block. So we're going to return coalesce. We're calling it optional else. I'm gonna call it the coalesce block. Synthesize block. I've done this before. So statements, parent scope, and span. Span is going to be the bin op span. Okay, 28 minutes. We can get this. If we can get this, or at least get pretty far, that would be something. So we're on track. This is cruising. So we need to make a variable. So good thing I have synth variable decal. Go to all. Is this still returning a triple? Oh my gosh, this really needs to return a struct. Synth variable decal. All right, so this accomplishes this makes us a variable. So name, and I think we're gonna do LHS value. LHS value. Opt-else LHS value is pretty useless. The initializer is the LHS expert. No mangle is false. We want this mangled. This is not something the user can access. Is mutable is false, and the owner scope is the coalesce block scope. Let LHS variable hate this. Self-ast identifiers dot intern what else LHS variable name. Do I have synth variable decal name? No, I don't. Okay. Oh no, where'd I go? So the reason this takes mute self, so I don't think that I'm allowed to inline this, though I will try. That's called scope ID. I don't have statements yet, so this will start off empty, and then we're gonna do coalesce block dot it has push statement. We can also push an expr as a statement. No, we want to push statement. So when I sent this variable decal, I get back a variable ID, a typed statement defining the variable, and a typed expr to reference the variable. So I want variable, sorry, ID I don't want, but I do want LHS variable decal statement, and I do want LHS expr variable expr. The LHS decal statement is going to be the first thing in our block. I don't want to forget to set the coalesce block dot I want to see if push statement still sets the type. It does still set the type. So that's fine. It'll take the type of the last expression. The main thing we want to do is set its span. Oh, but we already set it. So I think we're good. Get rid of this noise. Okay. Lose my train of thought every once in a while. It's really difficult to talk and program. Might go a little bit silent to write this. So if it's true, if it has a value, we want to do an unwrap. That's optional get, which I sometimes call it, which has inside it an optional get, which has an inner expr, and that's going to be the LHS variable expr, which we're using a second time, which is why I cloned it the first time. This does want to be boxed. The result type of this optional get, we're constructing it. This is usually populated by the type checker. We have to type check ourselves when we do this, so we want to be really careful. It's going to be the type that's inside LHS. So that's going to be LHS optional dot inner type. And the span is just going to be binop LHS dot we're just going to use the root span for everything. Checked. So checked is false. So codegen, if I say checked, well, it'll do an actual branch with a panic. And if I don't check, then it's just going to unwrap the value. The contract is that we've checked it with some sort of generated code, not that we've checked it with user code. In this case, it's because we've got the has value, and then this is going to be running after. So let's just make sure. Typed block. This needs to be a block. So coerce expert a block. Would you look at that? And then the scope of the expression. Yeah, okay. If it ends up being, so this is going to be our coalesce block. Otherwise, we're synthing a block. It makes a scope. Okay, yeah, that's right. It shouldn't really say expression scope. I guess it should. It should just say scope. Parent scope. Whatever. Alternate, and that's going to be RHS. We moved it, just Rust things. But we can do get type. Type ID is copy. So now we can just use RHS type instead of RHS get type everywhere. This way. I could have just reordered these two lines, by the way. The movement happens in order. These are guaranteed to run in this order. Coalesce block needs to be mute. Kind of our self is mutable because already barred is immutable. That's frustrating. So this whole thing, we're going to need mutable self. Okay. LHS optional. Let LHS inner. We're going to get the thing out of this that we need so that the borrow on self will die. And then we're going to use that instead. Whoa. So look, all the borrow checker errors go away except for, okay, type check types. Oh, I just messed this up. Let's change it all back. This is changing argument. I was changing in parens. Oh, some bad vimming just there. Okay, 39 minutes. I thought this would fail, borrow checking. This statement definitely needs to be. In our block. Okay, We have no more compiler errors. But do we have errors in our compiler? There's no error here. Oh, I'm running typer. Okay. So this is what happens when you try to run a Rust file. When I try to compile. I don't know why it fails in the prelude. Huh. Whatever. This is what I actually want to run. Okay. Else branch type did not match then branch type. Expected bool but got unit. Did I change anything in if else? Oh no, I broke parsing with the else thing. Function not found, maybe num in scope. That's good. So we print something side effecting to ensure we're only evaluating the expression once. This is fine. It'll compile now. Equals implementation for int question mark. Why would it even be trying to call equals? It's a bin op. It's acting like I did this. So we have maybe something up with our binary op kind. Keyword else results in a not equals. How about keyword else results in an optional else? That seems a bit better to me, huh? So yeah, we're compiling maybe num not equal 42. Let's run that again. Else operator can only be used on an optional type as bool. Okay, so now it's time to fix the parsing. So was I a bit ambitious? So let's go to prelude. This is saying line 86. Else. Okay. So the else is, of course, becoming part of the expression. So when I do an if, and there's no way to really tell it, hey, we're inside an if else. I think it's just a redundant grammar. So we could introduce a keyword or else. We could go back to double question mark. Bummer to hit a parsing snag though. Should have tested the parsing. I almost ran it, before doing all this type checking to see if we failed in the right spot. Hmm. Yeah, I was thinking about this case, and this parse is fine. The problem is, how do we know? We haven't type checked yet. This is now an expression. So I don't know if you mean that. There would need to be two. It's an expression. It's two expressions in a row. So I think it's just redundant. I'm gonna do or else. It looks so ugly. Let's use the double question mark maybe because it's known. I need to think about the syntax here. And then what failed in our actual, I don't think it failed in our actual program, only in the prelude. So if I remove, oh gosh, I'm actually gonna do this. It's in 3 places, 4 places. Yeah, no. Okay. We need to change the way we've parsed. So I didn't do anything in the lexer, but I did say I didn't even change anything here because this happens here. So it's still a binary op kind. It's just gonna be now here's a funny idea to use or. Nah, because it just means something different. Hmm. So if con expr else expr is our current dealio. So the problem is that this is now an expression of its own. I would need to pass down the context that, hey, we're inside an if else to not parse that particular binary op, which is really unpleasant. I could also make it a method on optionals. In Scala, it's get or else. Dot else? Dot else on optional? I like not introducing new syntax. So now we got to move all our code. All our code moves out of bin op into a special case method. Okay. It's not a bin op anymore. So that's going to mean the left-hand side is this expr and the right-hand side is the first argument to the function call. Is it such a common operation though that it merits not the extra noise of the dot and the parens, right? Is it really first class? Could also just do one question mark. Let's try this for now and hope it doesn't collide with something, because I think I'm only currently using it in type expressions. So that means it is a bin op. No, not equals, optional else. Okay. And this is question mark. And that means the change is as simple as that, I think. Maybe num, it printed it. Oh my gosh, it printed it and the assert succeeded. So let's dump let's dump our block. So we're making this block, right? So what we can do is we can self block. Hey, what happened to my stuff? So here's what we synthesized. Val dunder dunder opt else LHS 58. So that's the scope. So the idea is, well, at least I think it's the scope. This is part of the mangling. So when we sent the variable decal, yeah, it's the ID of the scope. So there can only be one name. And we own the scope because like the scope is literally the scope of this block. So this is enough to, we just need to dedupe it from all other scopes in which we are synthesizing variables. So if we did this exact same thing nested, then it would be 59, opt else LHS 59. Okay, that equals what they ran. And now if has value, then an unchecked unwrap, else 42. So I think that it actually worked. We got to test both cases. Maybe num, no num, some num. I think I'm gonna go with camel case for the language, but it's still TBD. So here's how the hinting works. Because we're expecting an int optional, and this is the last statement, it should lift it. I shouldn't have to put some here. So we have some num, no num. Let's test our shadowing. Some num. $41. Let's have some num do a totally different number. Some num should be 100. All right, and these each print only once. And just to prove that assertions work, let's try 101. Assert failed. Let's look at the machine code here. Optional coalesce. Oh, sorry. Optional coalesce. I can't search for these, by the way, because these are get ignored. So Z won't let me search for them. I need to figure that out. But I'm clicking on it with my mouse, like a Neanderthal. And main. Looks like this has been optimized. So we have an if cons and an assert.exit. And in the if cons, we print and then we just exit. So it's been so optimized that we can't even see our code. Where's our 42? Here's our 42. And then down here, we have our 101. We see a comparison with 101. See assign extension to a bool. Okay. This could be a bit more readable. I think my block labels are a little bad, or it's just been optimized so much that I can't really recognize some of the CodeGen artifacts. But we didn't really have to touch CodeGen because we just desugared. I mean, really all we need to look at is, the output here of what we desugared to, right? And we see that it's typed as int. It's kind of beautiful. Let's try true. And we've got else value incompatible with optional. Expected int, but got bool. And now let's put the left-hand side, something that is not optional. So we'll do 100. And we're going to say else operator, which I can now make, I can just say question mark. Question mark operator can only be used on an optional, but type was int. So those are some nice compiler errors. That's a nice feature, I think. So the last step is actually to move this optional coalesce into the test sources folder. And now we can run the full test suite, which should go from 50 to 51. And we should see our optional coalesce. Our optional coalesce in here, which there it is down at the bottom. 51 tests. So I can go ahead and commit that. So there's that CodeGen bug fix. There's that improved message. This needs to be fixed. So typer display. simple display for bin op kind. There you go. Just make sure I didn't mess up anything else or commit any accidental changes. We have this. I'm going to go ahead and commit the is this the working version? Okay, it moved, run file. I have to run the file again, fresh. I also want it not to print. Instead of printing, you know what? We don't need to keep any of the desugared stuff around. I think it's fine. Instead of print, oh, we need to check that it only runs once. It's not worth it. We tested it, and we wrote it in such a way that it doesn't reevaluate the expression, so that's probably good enough. Okay, I'm happy with that. So that looks now a little bit more committable. And non-coalescing operator to do, optional coalescing operator, binary operator, and we will cross that one off the list. All right, that is all. Implement optional coalescing binary operator. All right, thanks for watching.